Chapter 8, Section 3 in the 7th grade notes is entitled Line and Angle Relationships. So here we're going to study different types of lines and then also, more importantly, generally in parallel lines, the types of angles they create and the relationships between those angles. That study of parallel lines is really essential here as we start to talk about or prepare to talk about shapes, because a lot of the shapes that we talk about, especially the quadrilaterals, the four-sided shapes, have properties that are defined by the fact that they have opposite sides parallel. If we don't have an understanding of parallel lines, we're going to have a difficult time understanding the different properties of the different quadrilaterals. So let's go ahead and take a look at the definitions here. We've got the definition of perpendicular lines. Those are lines that intersect to form right angles. So when those lines meet each other, they're going to meet at 90 degrees. Parallel lines. Those are lines in a plane that do not intersect. So think of the top and the bottom of a brick. The top and the bottom of a brick, even though they're not lines, they are parallel. If they weren't parallel, eventually what would happen is the top and the bottom of the brick would meet each other, or the walls would end up meeting each other, and in that case all your houses would come tumbling down. So obviously you have to have parallel there to make a brick. Parallel means they will never intersect. Or if you want to think of it another way, they have the same slope. Skew lines. Those are lines that lie in different planes that are neither parallel nor intersecting. Now this is the hardest one for some people to understand. If I'm looking at the sheet of paper that the notes are on right now, those could be creating perpendicular lines or parallel lines or skew lines there. But let's say I float another dimension over the top like this. If I have a line on this sheet that's floating up here and another line that's on the sheet down here, those are skew lines because those lines are in different dimensions, different worlds type of idea here. They don't have anything to do with each other. Even if I draw one to go up and down here and one to go left to right here, that would be perpendicular. All right, because they're in two different slices of the earth here, they're never going to have anything to do with each other, so they're skew. It's only if I did that on the sheet of paper that's the notes right there could they end up then being perpendicular. So again, skew, those are lines that lie in totally different planes that are neither parallel nor intersecting. All right, some other ideas here. Adjacent angles, and these really come off the idea of parallel lines here. Adjacent angles are angles that have a common vertex and a common side but no common interior points. Vertical angles is a pair of opposite congruent angles formed by intersecting lines. And a transversal is a line that intersects two or more lines. A line that intersects two or more lines. All right, so let's go ahead and take a look here at number 1. In number 1, we're supposed to tell whether the lines appear parallel, perpendicular, or skew. And you've kind of got this pigpen type shape, this fenced in area here. And they're asking us about UV and YV. Well, as you can see, UV and YV are both on the back side of the pen here. UV is this line that runs left to right across the page, and YV is the one that runs up down. Well, if this is running left to right and this is running up down, you can see that here, there's your right angle. And if we have a right angle, that means they are perpendicular, which means that UV is perpendicular to YV. Now, in case you've never seen that upside down T symbol, that symbol means perpendicular. They're not making things up. That symbol actually means perpendicular in the math world. So since UV and YV appear to intersect to form right angles, they are perpendicular. Now we're asking you about XU and WZ. Well, as you can see, XU is in the back of the pen here, the back side of the fence, and WZ is in the front side of the fenced area here. Well, those are going to fit the definition of skew as we talked about earlier. One's in the back, one's in the front. They don't have anything to do with each other. That's like two different slices of the apple. As I showed the paper example earlier here, one's on this piece that's floating up here, the other one's in this piece that's down here. They don't have anything to do with each other. They're never going to do anything with each other. So that fits the definition of skew angles.